let's not get into that level, but wherever you see, you should see the consistent response out always. That's what is consistency means. Okay, is that clear?
Can you explain regarding atomicity?
Atomicity, let's take an example for atomicity. For example, let's say you are doing 3 operations. So let's take a case where I want to update the salary of an employee whose let's say whose service is greater than 5 years. 5 years by, let's say, by 10%. If you see here, everything, there is one update transaction, there is one select transaction, and again there is one update transaction. There is an update and there is a selection, right? First we'll select we'll retrieve all the employees whose service is more than 5 years. So there is one select statement, one selection, and then there is an update. But whenever we try to execute this, we will be executing it in one transaction only. But if you look at this, there are 2 small transactions within it, right? So that way a bigger transaction should be split into the minimal transactions, and they should be executed on their own, and on a whole the complete response should be persisted onto the database, meaning that should be saved onto the database. That is what is atomicity. Okay,
Thank you.
yeah. And isolation, as I said, right, so they should be able to execute them separately, meaning one transaction shouldn't impact the other transaction. Your UPI transaction shouldn't impact the withdrawals. So they all should be executed concurrently. That's what is isolation. Okay. Any other questions? Now let's see we are learning MySQL, right? What is MySQL? And you might have heard of Oracle, and then you might have heard of DB2 and all, right? Whenever you talk of database and all, you will be hearing all these terms. So what are these and how are these different from the database or SQL that we are trying to learn? These are the different products that are built on the database concepts that we have discussed right now, right? So they should be able to support the ACID properties. They should be able to support the DDL and DML commands. Like that, there are certain predefined properties of a particular database, and all those properties are being incorporated and being built by multiple vendors. So Oracle is one vendor who will sell the Oracle database. MySQL is from Microsoft, I believe, and DB2 is from IBM, and SQL Server is from Microsoft. So like that, every vendor has their own database products, and those database product names are MySQL, Oracle, SQL Server, so on and so forth. Okay, so they are all basically the database storing platforms that are available in the market. MongoDB is also there nowadays. It's NoSQL database and all. So currently, and one important point to note is that today in our course we'll be mostly discussing about the RDBMS database. DBMS means database management system, and RDBMS means relational database management system. So there will be a relation between the entities. So if you consider let's take an example of, let's say you are trying to build an let's say a HR management system, right? So in HR management system, you will have different modules, like let's say leave management system, and you will have a reporting structure and all those things, right? So will we store all these details in only one database table? Let's say I want to store my manager name, and I want to store the number of leaves I have availed and what are the leaves that are left over for me in that particular financial year. And I have my address details, my dependent details, my salary details, and all, right? So I might be having, as an employee, I might be I want to I want to store, let's say, 30 different attributes. Will I design my database in such a way that all these 30 will be in one row? No, we'll not design that way. We'll design those entities in such a way that one will be able to map the relationship between those things. For example, let's say I will create. We'll see the actual commands and all tomorrow because they will be very simple, but we'll try to understand the basics of it. Okay. In every relationship database, we'll have something called as entity and a relationship. What is an entity? Employee is an entity, and the let's say address is another entity, right? Employee has an address, so this is an ER. Every entity will have a relationship. So employee is an entity and address is another entity, and there will be having a relationship between these entities, right? Employee has an address. Similarly, employee has dependent information. Similarly, employee has leaves system. So if you see here, I am able to identify different entities I want to manage in my HR management system, right? And I'll be able to establish a relationship between all these entities. That is what we call as relationship database management system. What that relationship is, how do we maintain that relationship? The same address can be mapped to multiple. Let's say in an apartment there might be 3 employees that could be staying in a particular apartment. How do we identify between these 3? How is that relationship being maintained and all? We'll see tomorrow. But first you need to understand that whenever you talk about entity relationship database management system, we'll have an entity and we'll have multiple entities, and there will be mapped through a particular relationship. Is that clear?
Yes.
Yeah.
If you don't get any point, you can immediately stop me and ask me the question right then and there itself. You need not wait for till the end of the call. Okay.
Okay.
Yeah. So we'll have entities and there will be a relationship between entities. Now let's take an example of the employee database, right? How do I define an employee database? If you take any employee, you'll have an employee ID. He will have a name, right? He will have a date of joining, right? So my employee entity will have, meaning this entity, meaning it is you can consider it as a data or a group of data. So what are those employee entity will have? Employee ID, date of joining, and let's say name.
We are not able to see your screen.
Sorry. Somebody said something. I lost that.
Did you write something?
Okay. So employee entity will have multiple attributes like this, right? So of all these, if you look at this, what are the unique identifiers? What is that unique about employee ID? With what property of these 3 you should be able to identify an employee uniquely? Can date of joining be very unique to every employee? No, right? On a particular date of joining, multiple people could be joining, and as we all know that we have the names cannot be unique. Multiple people might be having the same name in an organization, but employee ID is very unique, right? No two employees will have the same employee ID, right? Yes or no?
Yeah, somebody speak, make it interactive.
Yeah, otherwise, I'm not at a point of. Sometimes I'm feeling like maybe I'm audible or not.
Okay.
So, employee,
People just responded what because he cannot think himself like so.
yeah, and
we
it's
are
not
in a
one-way
class.
traffic.
It cannot be one side story.
Yeah,
And others also be interactive and ask the questions and what is there and what is not there. Otherwise, it is a monotonous and monologue, right?
correct.
So generally, if maybe all are not employees, right, Venki? You take the class example. All will not have same roll number.
Yeah, correct.
Okay,
Same.
so
If you replace employee with class student, also it's the same, right? You will have a student roll number. You will have a roll number. You will have date of joining, name, and similarly, you might be having the in place of dependents. Maybe you might be having the guardian details, right? So, like this, you will, if you are planning to build any system, you will design the entities and their relationships first. That's the first phase of any particular design, right? So, based on the system that you are going to design, you will identify the entities and their attributes. For example, if you are planning to build a student management system, so what are the details that you want to manage in your system? For example, you might be wanting to store their roll number, attendance details, and the marks achieved and the grade, so on and so forth. There could be like 100 details, right? So of all those things, can we group few attributes into one entity, and can we logically group these entities and form an entity, logically group these attributes and form an entity. There is no hard and fast rule to say that this is the best way, but it depends on you with your experience or maybe with your common sense. We will group these attributes and we'll call them as one entity, right? That's why we don't say this is the best. There could be few best practices and all, but they are just the best practices. That's not the standard as such. Okay. Any questions on this entity relationship?
No.
So there are two types of relationships. One is a relationship and has a relationship. Okay. For example, student has marks, student has a grade, and the student is a human. That means, so every entity relationship diagram will have, and every entity relationship will broadly have is a and a has a relationship. So whenever you are trying to define your data structure, then you need to define it based on is a and a has a relationship. For example, student has an address, student has grades, student is a person, like that. So we will, whenever you are trying to design your entity relationship, we will take both these is a and a has a relationships into consideration, and we will create our entities. As we are trying to define these more and more, then we will identify that there are certain unique properties. For example, roll number is unique, right? For every student, you will have only one roll number. So like that, there will be, you will identify when you are starting to design your system and will go into the low level designs, then you will be able to identify the unique identifiers like student roll number, or maybe let's say the number of buses in your school. They will be very unique, right? You cannot have one number bus, two one number buses, like that. So that's very corner case. So you will identify what are the unique properties, what are the duplicate properties, and all those things, and hence you will be able to manage this relational database. Okay. Any questions?
So this what the difference makes between DBMS and RDBMS.
No. DBMS is like, this is what is real RDBMS. DBMS has multiple things like, NoSQL, and most of them these days there is no relationship database also. There is no they are designing databases in such a way that the relationship is not being maintained. But that's very advanced concepts. For now, we'll think that everything is RDBMS only.
I mean, can we have a mini
Example of what that no relationship database?
Yeah.
For example, let's say you are sharing the videos on a WhatsApp, right? What is the relationship between the video and you?
Okay.
There is no relationship, right?
So if I post my only video, then
Then you will not be storing it on WhatsApp.
okay.
That you will be uploading it to your Google Drive or maybe onto your photos, so that they'll be maintaining that relationship. This video belongs to person X. This video belongs to person Y, and person X has shared this video to person Y, like that. So when based on the system design, on the purpose that you have defined, based on the purpose that you have designed that system, you will decide whether you want to use RDBMS or no relationship database management system.
So one more thing, generally whatever you just to make understand at ground level is some tabular information you take as a relationship. Okay, of course some of the things which are not into table also can be called as a relational DB, but for the beginners you can think of, when you are creating a table will have some IDs now, whatever the student data or employee data, right? So in that certain things are kept in line. So those things, and if you are taking any file data, file in the sense what you call photos, pictures, or images, or what you call some PDF file, inside that lot of data is there. That is also information, but you cannot make what is what, right? So until unless you read it and get it, no, that will again for that NoSQL, there is another chapter for that. Okay, now we are not going that side. That is a correct me, Vinky, that is what is NoSQL only, right? No SQL or no something is there. So that those things doesn't fall under the RDBMS, and though they don't follow these formulas and all. Okay, that other side story. Generally this images and what is this, right? There is no link between one file to other file, but once we get the files to in our thing, then we try to sort them out and make them, we'll try to map to under some rules and all, then we try to use this kind of queries and all. Okay, unorganized data you can call it. There is NoSQL is another chapter, like another set of in the database management, if you call it from the high level, right? DBMS. So there is no.
Basically, this is like whichever data having a relationship, we can only manipulate or define those data.
Correct.
That's what
Yes.
makes DBMS.
Yes.
That's correct.
Fine.
So you'll be able to identify the relationship between two entities, then you call it as RDBMS. If there is no relationship, then there is no RDBMS. There is, I mean,
there is a MongoDB. Anybody heard MongoDB? Anyone heard that name? MongoDB something. That is now whatever Venki has written, a MySQL, Oracle, DB2. So those are falling under the RDBMS. So without RDBMS, that is called NoSQL. That is having different chapter and different set of rules and all. So completely unorganized data and all. But for that also some rules and some DBMS like MongoDB, even PostgreSQL also can do that activity. I don't remember exactly, but yeah, some different DBs are there for that purpose. Yeah, go ahead, Venki.
Hello. Hello.
Yes, Venki,
Go
go
on.
ahead.
Yeah. So, so as Sri Krishna just said, right? If as long as you can identify a relationship between two entities, we can build that using RDBMS. If there is no relationship, then there is no point of going for an RDBMS based system. Okay.
Yeah, got that.
Any other questions, guys? I take it as no. So as we are building this entity based relationship model, right? So as we dwell deeper into it, as we said, as we just discussed, right? So we'll be able to identify the attributes, and they will be able to logically group those attributes into entities. And then subsequently we'll be able to identify the relationship, like a student has grade, so on and so forth and all. So we'll come up with these entity relationships. So the basic outcome of all this low-level design should be you should be able to identify the entities and their relationships. Once you identify this, then you will identify that there are certain categories or certain attributes that are unique. We call them as primary keys. For example, whenever you are defining the student entity, then roll number is unique. We call it as primary key, meaning it is with that particular key you will be able to uniquely identify a particular student. Roll number 10 could be Mr. X. So with that, if you know the roll number, then you will be able to uniquely identify the person. But if you take Venkat, for example, it's very common name. So if you go to any class and will ask for Venkat, you will not be able to identify Venkat uniquely, right? Because it's the most common name. Similarly, Suresh, so on and so forth, right? So there are certain common names. So the name you cannot uniquely identify. Similarly, you cannot identify with the grade. In one particular grade, there will be multiple students. So as and when you are trying to logically group and separate them, you will what is unique to that particular property, and it is not always that there will be something unique. For example, address may not be unique, right? 2-3 children could be staying in the same apartment, same block. The floor numbers could be different, of course, but the possibility that 2 students could be staying in the same floor with different flat numbers. So it is not always mandatory that there will be something unique in each entity. At times there may not be same. That may not be correct, sorry. So at times whenever you define your entity, you may not be able to identify any unique property. So that time we'll decide what we'll create our own primary keys. Like for every record, I'll start inserting numbers, like first record 1, second record 2, third record 3, so on and so forth, and I'll create my own record if there is nothing uniquely available for a particular entity. Is that clear?
Yeah.
Okay. So we'll stop it there, and tomorrow we'll see this in action, like how do I create a table, how do I insert records, how do I retrieve records, what is that what is unique keys, what are foreign keys, what are primary keys, and all those things. We'll see it tomorrow.
I have a doubt here.
Yes, sir.
So since primary key uniquely identifies the object or entity,
Mm.
so what's the need of a unique key apart from
There is a small difference that we'll discuss tomorrow.
Yeah, sure.
Unique key can have a null, whereas primary key is non-null, and unique key can have a null. That's the only difference. There is no major difference. It's just a theoretical difference. And we don't use unique keys. We use only primary keys.
That's it. Thank you. Thank you very much.
Yeah, and also primary key, when I say uniquely identifiable, it need not just be one particular attribute name. At times it could be possible that if you group 2-3 columns, you should be able to identify a student unique, right? For example, Venkat studying in class 6 B section, with say 60% could be, if you say he passed exam with 60%, then you will be able to identify that who that Venkat is, those though there are two students in that same section, same class, right? So it need not always be only one particular attribute. At times, a group of attributes will also form the primary key.
Yeah.
Okay, it need not always be one row, or sorry, one column only. It could be group of columns also, or maybe my surname and with the same surname and name may not have to be two students with the same name and surname, right? So name and surname combination will become my primary key if I design my database like that.
Yeah, that's good.
Yeah. So we'll see all these things in action tomorrow, or some of them at least, if not all.
Team, make sure that you are install that MySQL DB, whatever Venki shared, no, that the WhatsApp group. So I think if you do not have that one, what do you call, there is no point in doing experiments actually. Okay.
Give deadline by 2 p.m. No?
And one more thing is, tomorrow I'll give you the exercise and I'll pick up one person and then we'll ask them to write the queries and all. Okay, it is not that I'll be doing it on my machine. Yeah.
Yeah, all ready. Get ready.
Yes, then we'll have fun tomorrow.
Yeah, thank you.
If anybody is facing any issues, just post the queries on the WhatsApp. Okay.
Hey, Krishna,
Somebody will
give
do.
them the 2 p.m. right? Tomorrow 2 p.m. is the deadline for fixing this MySQL.
Deadline could be anything that they need to install, right? Yeah. Okay. Okay, team. Bye bye.
Like 1 second, I have a question here for installing.
Yeah, please.
So when I try to install, no, I'm getting a message like get app from the store or change my app recommendation setting. It is not a Microsoft verified app.
Okay, can you share the screen once?
Yeah.
Venki, you shared that MySQL DB, that authentic, that only, right? That
Correct, from that site only.
yeah. Did you install from that only or some other place?
No, same from that site only.
Okay. Who hijacked that then? Karthik, are you sharing the screen?
Yeah, 1 second.
Verified user account of that Windows laptop.
Oh, that also there now.
Yeah. Previously, I tried installing on one of the pirated machines where I got the same issue.
So to learn this, we need to pay to Microsoft then.
See, I'm getting a message like this.
Change my app recommendation settings. What is that saying?
This one.
Installing apps. You in the first drop down the Microsoft store only. Can you change it to anywhere?
Anywhere.
Yeah. Close this and try installing it again. Yeah.
Okay.
Okay.
So,
Complete. Install, and it will follow the steps that I have shared in the document, and it should be.
okay. Yeah. Okay. Fine. Thank you.
Thank you, guys. Thanks for your time.
Thank you.
If you face any